Okay, last time we talked about how the voltage source shows up at 9 volts at our barrel connector here. This time I want to look at that voltage across these various power outputs, and I want to do so in a way that makes it easy to work and easy to see. So often beginning electronics can feel daunting just because it's hard to see what's going on. Okay, if you're looking at a genuine Arduino, the first thing you want to look for is this on label and the LED next to it. It should be glowing. That's your confirmation that 9 volts of DC power are on the board. And if you've got some off-brand Arduino, just find the on button somewhere else. And here, it's red instead of green, but its function is the same. It's glowing, telling me that I have power on the board. Open up your components box and find the header pins and take 2 of them out. Go ahead and stick one of them down into this socket for 3.3 volts. And don't worry about how one of the legs is going to be dangling off into the air. Then get your other header pin down into the GND socket, the ground socket. And you might notice there's 2 of them. You can put this in either one. Okay, now imagine the simplest circuit ever. It's going to begin on the positive side at 3.3 volts, and it's going to go around to the ground. And we're going to think of the ground as the negative side of the circuit, and we're going to imagine that a current always flows from the positive side to the negative side. But we're not actually going to build this circuit because this is called a short circuit. It would immediately draw all the amperage available through the circuit and damage the Arduino board beyond repair. And this feeling too can make it daunting to get started with electronics. Oh no, what if I break it? Well, these Arduino boards are not terribly expensive, so it is not the end of the world if one explodes. And explode just means that that tiny little LED is going to go dark and not come back. Okay, so what do we do? How do we hook up a circuit that doesn't immediately short the board and destroy it? The answer is we provide resistance. The unit of resistance is the ohm, named after Georg Simon Ohm. It is written as the Greek letter omega, probably because omega sounds like ohm. On an electrical diagram, a resistor is indicated as a squiggly line with the letter R nearby. So, in real-world terms, over here our voltage source, the positive side, is going to be our 3.3 volts, and then a wire is going to connect to our resistor, and then at the other side of our resistor, a wire is going to come back to the ground, the negative side of our voltage source. Okay, but what's our resistor? Well, for now, it's going to be the multimeter. With the probes of the multimeter, we can touch the 3.3 volts and the ground without destroying the Arduino board. So let's do it. Turn the multimeter on to volts measuring DC current, and then with the probes, touch the red probe to the 3.3 volts and the black probe to the ground with confidence, knowing that you're not about to create a short circuit. And then watch the screen of the multimeter settle in on 3.3 volts. Okay, now let's add a component to our system that gives us an easier place to work. And for beginning electronics, this component is called the breadboard. It's called this because early electronics prototypers used to screw right into a cutting board that used to hold a loaf of bread. It's got a bazillion holes in it into which you can stick jumper wires, and they're organized in the following way. Look at this bottom row. Every hole on the row is connected to one another. Check out this breadboard that's had the backing ripped off. Can you see this metal rail that runs all the way along the edge? That's your bottom row, and that metal connects every hole to every other hole on that row. It's the same for one row up. There's a metal connector running the entire length of the breadboard. Then the pattern changes and you get a whole bunch of shorter rails. Each one of these only connects 5 of these jumper cable holes. Okay, let's try it out. Get 2 jumper wires, a red one and a black one, out of the box of jumper wires. Then pull out your header pins. We're going to use those in a moment, so keep them nearby. And plug your red wire into 3.3 volts and your black wire into ground. Now your 3.3 volts is the positive side of your circuit, and so let's plug the other end of the jumper wire into this long rail on the breadboard with the red plus sign, the positive rail. And when you do, imagine that you could pick up that positive voltage from any other hole on that rail. And then take your ground wire and plug it in way over here on the negative rail. Why not the negative rail close to the positive? Well, this one's just so far away that it makes it a bit easier to see what we're talking about. Look at how this gives you some room to work without your fingers always crashing into the wires. Go ahead and put your header pins down at the bottom of each rail. Good, now you can imagine that you've got 3.3 volts pressurizing this rail, but because the bottom rail is not connected to the one at the top, the electrons cannot flow. The circuit is open. And it's a good thing that it is, because if I closed it with a wire, I'd create a short circuit and blow up my Arduino. Okay, now connect the probes of your multimeter to the header pins. And if you've been wondering why I use 2 header pins, it's just because they kind of cradle the probes of the multimeter, making it a little easier to make contact. And then confirm that you really do get 3.3 volts measured on the multimeter. Good. This setup makes it really easy to now experiment. Go ahead and switch your red jumper wire from 3.3 volts to 5 volts and check your header pins on the multimeter. If you're not getting positive 5 volts, take a moment to ask why. And for the final test, take your red jumper wire out of 5 volts and plug it into V-in. You can think of V-in as the same voltage as what's coming in the barrel connector. And if we put the probes of the multimeter onto the header pins, we should get 9.22 volts, but we only get 8.36. Why? Well, between the barrel connector, where we have 9.22 volts, and the V-in pin, where we're only reading 8.3, there is a component that is consuming a bit of our voltage. And it's right here under my thumb. It's called a diode. It is the reverse polarity protection diode. Remember when we were looking at the power adapter itself, and at this diagram that showed us that the inside of the barrel connector was positive? Well, you can get this exact same barrel connector on a power adapter where the polarity is reversed, where the inside is negative. And if you plug that into your Arduino, you would fry the board, if not for this little diode protecting you. It's consuming about 0.8 volts, but for the protection that it offers, it is definitely worth that drop. Next up, we're going to get to know resistors and how important they are when setting up components like LEDs, which would immediately die if given too much current.